All right, activity 20 still, solving simple trigonometric equations. We're still going to do one that we can do by hand. Now keep in mind, it's going to be the exact same procedure as the last two we did, but there's one extra little step I need to show you in here. And these can be found on the unit circle. If you get to the point where you have to do arc sine, arc cosine, arc tangent, and it's not in the unit circle, you would actually find your angle then by using a calculator, making sure you're in the right mode. If it's a degree, you need to be in degree mode. Radian, you need to be in radian mode. And then use that angle you find to actually find your reference angle, depending on what quadrant it's in, if it's in quadrant 1, 2, or 4. So I'm not going to show you one with the calculator simply because it's the same procedure. It's just a matter of, instead of using your unit circle to find your angle to find your reference angle, you're going to use a calculator to find your angle to find a reference angle. However, in try these D, letter B, there's a little trick I want to show you guys, because I only taught you arc sine, arc cosine, and arc tangent. Even there is an arc secant, arc cosecant, and arc cotangent, nobody really uses them because there's a nice little trick that you can actually do. So let's go ahead and solve one. So on try these D, letter B, we have negative 6 cosecant theta minus 7 equals 5. And it tells you it wants your answers between 0 degrees and 360 degrees. They're really nice to you. They actually let you use degrees instead of radians. However, I think radians are actually easier to deal with. However, degrees don't have really fractions when we're dealing with the unit. They don't have any fraction when we're dealing with the unit circle. So first thing we have to do, same as the last time, we must isolate our trig function first. So we're going to use a little bit of algebra here. We need to add 5 to both sides. That's going to give me negative 6 cosecant theta equals 5 plus 7. We have to add 7 because we're subtracting 7 on right here. So we need to add 7. Well, negative 7 plus 7 gives you 0, so it goes away, and that's why I don't write it here. But we have to add 7 here. That's going to give me negative 6 cosecant theta equals 12. Now we're multiplying negative 6 by cosecant theta, so we divide both sides by negative 6. These cancel, and 12 divided by negative 6 means that I'm going to have a cosecant theta equals negative 2. Now here's the trick I'm telling you guys about. We know that cosecant is in reality 1 over sine. We've talked about it because of the reciprocals. And that still equals negative 2. Well, I have arc sine, so what I do to one side I can do to the other. I'm actually going to flip both sides upside down. I'm going to take the reciprocal of both sides, and that's going to give me sine theta equals negative 1/2. Cosecant of negative 2 is going to give you the same thing as sine theta of negative 1/2. And now we can use sine, cosine, and tangents because that's what we're used to seeing on the unit circle. Cosecant and secant and cotangent, they take a little bit more math than sine and cosine and tangent. So now we want to isolate our theta. We're going to do arc sine on both sides. So my theta equals arc sine of negative 1/2. Well, arc sine, where are we going to find our answers? Cast, C-A-S-T. They are negative in quadrant 4. So we're going to be looking at quadrant 4 for a y value where it is negative 1/2. Keep in mind this is in degrees. So my theta is going to equal negative 30 degrees. I want to use this angle we just found to find my reference angle. This is in quadrant 4. So we just simply take the absolute value. So my reference angle phi is going to be the absolute value of negative 30 degrees, which is nothing more than 30 degrees. So now I have my reference angle. So now we just simply need to solve this problem using my reference angle. Well, the problem we're going to work on solving is going to be sine of negative 1/2. All of this up here, while it's still important, this is ultimately what I want to use because this is what I want to need for my unit circle. I need to ask myself, what two quadrants is sine negative in? Well, we go back to our good old friend, all students take calculus. All students take calculus. We know sine is positive in quadrants 1 and 2. Therefore, it must be negative in quadrants 3 and 4. So my answers I need to use my reference angle to find are going to be in quadrant 3 and quadrant 4. So, quadrant 3. Quadrant 3 is going to be 180 degrees plus my reference angle, which is 30 degrees, which gives me 210 degrees. In quadrant 4, we're doing 360 degrees minus my reference angle, which is 30 degrees, which equals 330 degrees. Therefore, my solution to theta is going to be the set of answers of 210 degrees, comma, 330 degrees. Once again, I use theta instead of x because theta was what was given to me in the original problem. I expressed my answers in degrees because the restriction they gave me on my answers was given to me in degrees. The only two answers, 210 and 330, is in fact in between 0 and 360. All the other answers would either be negative or positive greater than 360, so I wouldn't use them. Same procedure as the other ones. The only difference is this trick right here. We use the idea that it's the reciprocal, and we make our life easier by simply doing sine instead of trying to do arc cosecant.